Imagine a world where almost everything dies, not just a few species, or even a lot of them. A planetary-scale catastrophe so profound it nearly wiped out life itself. This isn't science fiction. This is the Permian-Triassic extinction, an apocalypse over thousands of years, but in Earth's timeline, a sudden, brutal snap. Life had been thriving for hundreds of millions of years, evolving into a weird, wonderful menagerie. Then, in a geological instant, the music stopped. The world fell silent. The sheer scale is almost impossible to grasp. Think about every person you know, every animal you've seen in a zoo, every insect buzzing in a garden, every fish swimming in the sea. Before the world ended, it was teeming with life. This was the Permian Period, a time stretching from roughly 299 to 252 million years ago. Imagine a world with one giant supercontinent, Pangaea, stretching from pole to pole. This massive landmass created extreme climates. The interiors were incredibly dry and arid, while the coastal regions were often swampy and humid. It was a world of contrasts, and the life that evolved to fill it was just as strange and spectacular to our modern eyes. This wasn't the age of dinosaurs. Not yet. The dominant land animals were creatures called synapsids, which are often mistaken for reptiles but are actually our very distant relatives. They were part of the group that would eventually lead to mammals. The end of this vibrant world wasn't instantaneous, but it was terrifyingly fast in geological terms. The Great Dying occurred approximately 252 million years ago, marking the boundary between the Permian Period and the beginning of the Triassic Period. For scientists, this boundary is not just a line in a textbook. It's a physical layer in the rock strata found all over the world. Below this line, the rocks are filled with a rich diversity of Permian fossils. You find trilobites, gorgonopsians, and a whole host of other creatures. Then you cross the boundary, and above it, there is almost nothing. It's a layer of rock that paleontologists call the dead zone. Pinpointing the exact timing and duration has been a monumental task for scientists. By studying layers of volcanic ash trapped in rock formations in China and elsewhere, geologists have been able to date these events with incredible precision. Their findings are chilling. The main pulse of the extinction, the phase where most life vanished, may have happened in as little as 60,000 years. The devastation in the oceans was almost total. While life on land suffered immensely, the marine realm experienced a near-complete wipeout, with an estimated 96% of all species disappearing forever. The vibrant, complex marine ecosystems of the Permian simply ceased to exist. The vast reefs built by ancient corals and sponges died off completely. For millions of years, the world's oceans were essentially reefless. The oceans became a silent, stagnant world. What could possibly kill on such an unimaginable scale? The evidence points to a cascade of horrors. As greenhouse gases flooded the atmosphere, the planet warmed dramatically. This warming heated the oceans, which can't hold as much dissolved oxygen as cold water. This led to widespread anoxia, a lack of oxygen. They suffocated in the water that had once given them life. The oceans were literally gasping for air. Almost everything with gills was doomed. The same greenhouse gases dissolved into the seawater, causing ocean acidification. Carbon dioxide mixing with water creates carbonic acid, which made seawater corrosive to organisms that build shells or skeletons from calcium carbonate. Reef builders, shelled ammonites, countless brachiopods, their protective homes literally began to dissolve. While the oceans faced a chemical apocalypse, the supercontinent of Pangaea was not spared. About 7 out of every 10 vertebrate species on land went extinct. The great synapsid empires, the saber-toothed gorgonopsians and the giant armored herbivores they hunted, were completely annihilated. These creatures had dominated the planet for millions of years, but were wiped from the slate. The forests they roamed also suffered. Fossil evidence shows a massive die-off of the dominant Glossopteris trees, leading to what scientists call a fungal spike, a layer of rock unusually rich in fossilized fungal spores, indicating a world covered in dead and rotting wood. The conditions on land would have been brutal and unforgiving. The same greenhouse effect that was choking the oceans was baking the continent. Global temperatures soared, potentially rising by as much as 10 degrees Celsius, turning interiors into uninhabitable superdeserts. Simultaneously, acid rain stripped vegetation, poisoned soils, and tainted freshwater sources. The world's forests withered and died, leading to massive soil erosion. Without plant roots to hold it, soil washed into rivers and oceans, further choking struggling marine ecosystems. The survivors on land were, for the most part, small, hardy, and adaptable. One of the most famous is a creature called Lystrosaurus, a pig-sized, beaked herbivore that, after the extinction, may have accounted for as much as 90% of terrestrial vertebrate life. So what was the trigger? What single event could unleash so much chaos? Most scientists point to one prime suspect, an enormous volcanic event. Not a single explosive volcano like Mount St. Helens. A different kind, a large igneous province. In modern-day Siberia, the ground split and lava poured out. Fissures produced flood basalts layer after layer for hundreds of thousands of years. This is the Siberian traps. The scale is staggering. An area around 2 million square kilometers, bigger than Alaska. In places, the stacked lava flows are several kilometers thick. Total volume between 1 and 4 million cubic kilometers. Enough lava to bury the continental United States hundreds of meters deep. A planetary resurfacing that bled molten rock for millennia. The timing aligns with the Permian Triassic extinction. Radiometric dating ties the Siberian traps to the extinction layers. Eruptions began just before and continued through the extinction. This isn't coincidence, it's the geological smoking gun. The lava devastated locally, but the real weapon was what the volcanoes released into the atmosphere. Magma ripped up through a crust rich in coal, carbonate rocks, and other organic deposits. The heat cooked those deposits, releasing huge amounts of carbon dioxide, methane, and other greenhouse gases. It became a runaway geological process. Volcanoes emitted gases and cooked more rock, releasing still more. That colossal pulse of carbon was the first domino, setting off climate change and ecological collapse, the Great Dying. The Siberian traps provided the trigger, but the kill mechanism was the cascading environmental collapse that followed. The first and most direct effect was the injection of massive quantities of greenhouse gases into the atmosphere. Carbon dioxide, methane. They trapped heat, leading to runaway global warming. Global average temperatures may have soared by 10 degrees Celsius or more, pushing many species past their limits. The warming hit the oceans hard. The global ocean circulation may have slowed or stopped. When the conveyor shut down, the deep ocean became anoxic, oxygen-deprived. The geological record confirms this. Volcanic eruptions also spewed sulfur dioxide and other aerosols into the sky. Those particles may have briefly cooled the planet by blocking sunlight, further stressing ecosystems. Worse, they created intense acid rain. Sulfur dioxide plus atmospheric water formed sulfuric acid, which fell as rain and devastated forests, poisoned soils, and acidified lakes and rivers. The combined effects created a deadly feedback loop. Forest die-off meant less CO2 absorption. Decaying biomass released more carbon and methane. Death of marine plankton stopped carbon sinking to the seafloor. Earth's life support systems weren't just failing. They were reversing, driving the world into a hothouse state. The story of the Great Dying is not speculation. It's a scientific theory built on decades of meticulous detective work. The primary evidence comes from the rock record. In places like Meishan, China, the Permian Triassic boundary is perfectly preserved. Below the line, a rich fossil record. Above it, a stark, dark shale almost devoid of life. Geochemists analyze the chemical composition of rock layers to reconstruct the ancient environment, measuring carbon and oxygen isotopes. A sudden dramatic shift in carbon isotopes worldwide points to a massive release of light carbon into the atmosphere, from burning organic matter or volcanic gases. Further evidence comes from biomarkers, molecular fossils. Scientists have found chemical remnants of green sulfur bacteria in rock layers from the Extinction period. These bacteria thrive in anoxic, sunlit waters rich in hydrogen sulfide, evidence that oceans were toxic and periodically venting poisonous gas. Radiometric dating on Siberian volcanic rocks establishes a precise timeline that matches extinction dates thousands of miles away, a powerful correlation. The Earth left behind the murder weapon, the victims, and the chemical clues needed to solve the case. The correlation between the volcanic event and the biological crisis makes it clear they are cause and effect. The story of the Great Dying is more than just a fascinating chapter in Earth's deep history. It serves as a profound and chilling warning. It is a detailed case study of what happens when a massive amount of greenhouse gas is rapidly injected into the atmosphere, triggering runaway climate change. The processes that unfolded 252 million years ago are eerily similar to the environmental changes that are beginning to unfold today. Global warming, ocean acidification, widespread anoxia, albeit driven by human activity rather than volcanoes. The speed of the ancient catastrophe is perhaps its most important lesson. The main pulse may have occurred over just 60,000 years. Today, we are releasing carbon into the atmosphere at a rate that is likely even faster than what the Siberian traps managed during their peak. We are conducting an unprecedented geological experiment on our own planet, and we are the only species around to witness and bear the consequences of the results. The resilience of life is the other side of this story. Life did not end. From a few survivors, life slowly rebuilt itself over millions of years. The extinction cleared the way for new forms: dinosaurs, then mammals, and much later, us. We exist because of this catastrophe, but that offers little comfort. Studying the Great Dying is about understanding our vulnerability and our responsibility as stewards of the planet. It is our choice whether we heed the warning or follow the same path. The ghosts of the Permian have a story to tell, and we would be wise to listen.